So this is the tutorial for the security and privacy session at MobiSys 2021. So security and privacy are increasingly important topics. I don't think I need to spend a lot of time motivating them. We are all aware of all the attacks that are targeting different parts of our computing infrastructure. And these attacks are extremely concerning because not only they can cause significant financial loss, but also they can cause catastrophes, social issues. All right, so when I was asked to do a tutorial on these topics, at first I was not sure how to go about it because they're obviously very broad topics, right? They cover different aspects of computing. So I decided that I needed to somehow narrow the scope of the presentation. And what I decided to do was to try to answer this question on like what security and privacy problems has the mobile community, like SIG Mobile, been working on in the past 5 years. Okay, so a couple of disclaimers and details about my approach, right? So what do I mean by the mobile community? I mainly mean the papers published at MobiSys and MobiCom, like two of our top conferences. There are other top conferences in SIG Mobile, such as Census and UbiCom, but I did not cover those in this presentation. As you will see, I will try to categorize these papers into some kind of like high-level categories, just to give us a kind of like a high-level sense of the papers. And it's very likely that I might have miscategorized some of the papers. If that's the case, I apologize to the authors. And the categories that I came up with are somehow impacted by my own research taste, although I did try not to let that be a major factor. All right, so before giving you the categories, let's first look at some fun numbers, right? So I was actually curious, like on how many security and privacy papers have been published in MobiSys and MobiCom. So I went through the past 5 years of these conferences, basically 2016 to 2020. I tried to identify all the papers that can be categorized as security and privacy. Some of them were easier. They're under the sessions named security and privacy, but there are other papers in other sessions as well. And here are the numbers, right? So you can see that there have been a good number of papers on this topic showing up in our conferences, right? MobiSys, especially at MobiSys, we've seen on average about 10 such papers. Also, if you look at the percentages, right, it could be a large percentage of all of the papers published at the conference. Like we've seen 30 to 40% at MobiSys. So more than MobiCom. And another interesting issue is that some of these papers with MobiSys have been winning best paper awards. So I've highlighted the years that this has happened. All right, so all of this shows that our community is interested in the topic. It knows its importance, and especially there are a lot of efforts on it recently. All right, so as I mentioned, I wanted to categorize all these papers, and there are various ways I could have gone about this. For example, I could just have two categories, attack papers versus defense papers, or like categorized based on the platforms that the papers are targeting, the smartphones, drones, voice assistants, or just look at systems versus theory, etc. Right? But instead, what I decided to do was try to categorize based on different components of mobile computing that the papers are targeting. Okay, and to be able to do this, I needed to have like a very simple view of the ecosystem of research in mobile computing, right? So I came up with this like very simple figure, right? Of course, it's missing a lot of details, but I think it's going to do a good job in helping us I see the categories, right? So if you look at a paper, a mobile computing paper, right, you might see like typically a user, right? The user interacts with some mobile device, right? Smartphones, like a voice assistant, tablet, wearables, right? And then these devices on their own communicate either to some other devices or to an access point or a base station through which they can then reach some servers in the cloud, right? As you can see, this is a grossly oversimplified view of the big picture, right? It's missing a lot of details. For example, we're not even showing the edge here, right? So I just came up with this because it has all the components for the categories later that I would like to cover. All right, so now let's start from the left and see like the security and privacy papers targeting different components in this figure, right? So let's start from the user, right? So the relevant papers that we've seen are mainly on authentication and identification of the user. Especially, we've seen a lot of such papers at MobiCom. I think in general, like mobile devices, as we all know, have a lot of sensors, right? And the sensors can capture very interesting signals. So people have looked at how the sensors can be used for authentication, right? So let's look at the subcategories here. And we've seen papers that try to authenticate the user using very different factors, right? So we've seen papers that do authentication based on something you are, right? So for example, based on your breathing pattern or your heartbeat, etc. Right? We've seen papers that do authentication based on something you have, like maybe you have a ring that you can use for authentication, or you own a wearable device that is paired to a device that you want to authenticate yourself to, or maybe you're wearing a motion sensor that can pick up the vibration when you speak, and that can be used for authenticating you to a voice assistant. Okay. We've seen authentication based on something you know. So you know something, then there's some signals in your brain that can be picked up for authentication. We've seen authentication based on somewhere you are, right? Like, for example, if you're close to some device, then you can authenticate, or based on something you do, right? For example, how you swipe on top of the screen of a mobile device can be used for authentication. Okay. So we've also seen some attack papers here. So for example, if keystroke dynamics are being used for authentication, then an attacker can try to mimic how the user type in the password, right? So we've seen attack papers as well. So related to this, we've also seen a paper on liveness detection. The goal here is not necessarily just authentication. The goal is to detect whether like the device is interacting with a real person, right? So this can be used as part of an authentication. For example, you want to make sure that the face that you're seeing in front of a mobile device is not like a cardboard, like a printed face on a cardboard, right? It's a real 3D person. All right, so let's go a little bit further to the right, right? Now we're talking about the interaction with the device, basically the inputs and outputs, the user interface. Right? So we've seen work related to input, and specifically we've seen work that try to come up with solutions that eliminate spoofed inputs, right? So what we're trying to do here, let's say there's a smartphone, right? You're an app, and there's a button on the user interface that can be clicked by the user. You want to make sure that if there's a click, this was a real user pressing on the touch screen, right? That it was not some event triggered by software on the device, right? Some malicious software, right? Or similarly for a voice assistant, if you hear a command or like a voice command, you want to make sure that this was actually spoken by a user, right? So this is related to the input. We've seen work related to the output, right? Securing the output. Some work try to make sure to keep the output that is about to be shown to the user confidential, right? So like even like software on the device can't really access the output, right? Like the operating system, for example. Or like we've seen work that try to protect who can actually see the screen, right? And this to limit who can actually view the content on the screen. And this can, for example, help us protect against shoulder surfing attacks. And we've also seen some attack papers here as well, like basically a study of attacks using some UI feature. All right, so let's go a little bit further to the right. Now we want to talk about the mobile devices, the platforms themselves. And there are a lot of work related to this part, so I had to further break it down, right? So if you look at it inside a mobile device, you will see some hardware and software, right? So on the hardware side, you have like a CPU, like memory, different I/O devices such as sensors, and then you can there are also different software components. For example, trusted execution environments, hypervisors, operating system applications, etc. So we've seen work, security privacy work related to pretty much all of these components, right? So let's go through them. I'm going to start from hardware, and let's start with sensors, right? Because as I mentioned, mobile devices have a lot of sensors. So like we've seen a lot of also security work related to the sensors. Out of all the sensors, there are some of them that have seen a lot of research on when it comes to security and privacy. One of them is camera, and it should be obvious why, right? Because the camera can capture a lot of content, potentially a lot of private content. So some of the solutions that we've seen try to limit what a camera can capture. So for example, maybe if maybe the user can somehow in the physical world highlight the areas that need to remain private, and then a camera which is aware of like the policy will basically crop those regions out, right? Or if the camera is itself is not trusted, we've seen work that try to illuminate a certain private space with some light patterns that make it like pretty much impossible for a camera to capture, right? Related to this, we've seen work that try to help the user against malicious use of cameras, for example, to notify the user if the camera on a phone is recording, or to help the user detect spy cameras, etc. Right? We've also seen actually work on helping with providing some information about when a content was captured by the camera, for example, the time, right? So it's a slightly different problem, but still related to the cameras. The other sensors that has seen a lot of work is GPS and location in general, right? It's not surprising. Location is also an important signal. So some line of work that we've seen is on spoofing the GPS readings, right? We've seen work that try to make the GPS spoof resistance, or actually try to mount location spoofing attacks, right? We've also seen work that try to, for example, defeat Sybil attacks on mapping services. So when it comes to sensors, another security issue is side channels and covert channels. So basically, what it comes down to is that a sensor is typically designed to pick up a specific signal, but it might end up picking up another signal that it was not intended for, right? So think about a motion sensor, right? So the motion sensor can pick up the vibration, but if the vibration was triggered by some audio, like someone's voice, then now the motion sensor suddenly is acting as a microphone, right? So and basically that's kind of like a side channel, or if malware is aware of this, they can use this channel to secretly communicate, and it becomes a covert channel, right? So that was one example. And another example is if, for example, we have voice commands send over in frequencies that are not audible to the user, but they are picked up by a microphone, which is something they're not intended to do, then that can also be used as some form of a side channel or covert channel. All right, so, and then we've also seen some papers that try to do sensing, but while respecting the user privacy, and this is specifically important when it comes to health-related signals. All right, so with other hardware components, we have not seen much work. We've seen a work on CPU where it tries to defeat cache side channel attacks on ARM processors, but we have not seen papers on other hardware components, such as memory, for example. All right, so let's go a little bit higher, trusted execution environments. And there's been quite a few papers that try to use TEs to implement some form of a security feature, right? For example, we've seen papers that try to use the TE to do to control the peripherals, like such as cameras. And TEs, by the way, the benefit of TEs is that they're isolated from the rest of the system software, right? So even if your operating system is compromised, you can still rely on the TE. So that makes the trusted computing base of your solution a lot smaller. We've seen work that try to use the TEs for secure input and output, and I mentioned some of these earlier, right? And indeed, one of the papers in today's session is going to be related to this, right? Rushmore, which tries to secure the output, like shown to a user using TrustZone, which is a TE solution for ARM processors, as well as some other hardware features. We've seen the use of TEs to secure applications or like certain frameworks, such as machine learning frameworks. And another paper today, PPFL, is going to be on this topic, right? So, and also we've seen a paper on trying to think about the structure of the software within the TE to again to minimize the trusted computing piece. All right, so let's go a little bit higher. The operating system. We've seen work related to operating system security, seen work that try to do analysis on the OS to detect vulnerabilities. We've seen papers related to security frameworks within the OS, such as like the permission system. And one of the papers today, Safety Knot, it's going to be a study on a security feature in Android called Safety Net, right? That can be used for attestation. We've seen papers that try to study the vulnerabilities and attack vectors within the operating system as well. For example, the use of the device admin interface in Android. All right, then finally, apps, right? So there have been some paper, I have to say I expected to see more because in general, in other communities, we've seen a lot of security work related to apps, for example, Android apps, but there were not as many when it came to MobiSys and MobiCom. The ones that we've seen are like, for example, try to tame misbehaving apps, right? Maybe we would like to make sure that the apps cannot leak some private information, or we would like to be able to isolate various modules within the app, such as libraries. We've also seen work that analyze application. For example, they do some information flow tracking of the application. And we've seen some work related to frameworks within the app that have security implications, such as dual instance apps. All right, so we're done with the platforms. There are two more components I want to cover, the network, and then after that, the cloud. So it's not surprising that there's been a lot of network security and privacy papers in our conferences, and there are various categories and like various different issues that they've tried to target. We've seen papers related to eavesdropping on the traffic, right? Either eavesdropping itself or to try to detect a potential eavesdropper. We've seen papers that try to help securely audit the traffic. We've also seen, again, papers related to side channels and covert channels, because your traffic, even if encrypted, it might still reveal some information, right? So there might be some side channel there as well. We've seen some interesting papers related to secure or secret or group communication between different users who would like to establish a communication channel. We've seen papers related to vulnerabilities in the networking stack, for example, in the Bluetooth stack. And like a line of work that we've recently seen more work on is on the security of cellular networks. So far, at least, let's say for me, I've always like treated the cellular network as kind of like a black box, right? But now people are poking in and trying to find the vulnerabilities in the protocol and how that could be abused by attackers. For example, we've seen work that show that these vulnerabilities can be used to spoof the caller ID or spoof a wireless notification sent to many users, or to issue ghost calls. So the last component that I want to cover is the cloud. And again, like these are all papers in MobiSys and MobiCom, right? So they're not exclusively about the cloud. It's about the cloud and its usage on a mobile device, right? So the papers that we've seen, like related to security privacy, one important category is what I would like to call on-device processing for enhanced privacy. And in fact, 3 of the papers in our session today are going to be related to this topic: PPFO, Megamind, and encrypted cloud photo storage. So what is this category in general? So on our mobile devices, we do use a lot of services provided by the cloud, like pretty much any app that you use, or like any web apps that you use, right? They do use some services in the cloud, and in doing so, we typically reveal a lot of private information, right? Such as our preferences, or maybe our voice commands, etc. Right? So these papers, what they try to do is to do some processing locally on the device before reaching out to the cloud, with the hope that we can provide the same services to the user, but without giving up our private information, right? So for example, the papers that we're going to see today, they do that for voice assistant, right? Or let's say if you would like to use the photo storage in the cloud, maybe we can use that, but like have our photos being encrypted. All right. So the other couple of papers that we've seen related to the cloud is related to identification of mobile devices in the cloud, which is used by advertising networks. Or we've seen work on secure use of the cloud for enhanced performance. Basically, you want to offload some computation, how can you do it securely? And we've seen, for example, the use of SGX enclaves remotely. And we've also seen the work on trying to authenticate the server from the mobile device. So that's pretty much it. Thank you for listening, and enjoy the session.